For the panel part of today, we're going to be focusing on this idea of kind of data science in a changing world. And it's because two things are happening, right? Or three things are happening. First of all, the world is changing a lot. Things are changing, and particularly the types of things that we measure and focus on in data science are really rapidly changing. Second of all, our access to data is changing all of the time. When I think about the data that was available when I was in university versus the data that was available when you guys were in university versus now, like that is three really different stages for a field. But also, like, the field of data science is changing itself. So what we think of as data science, how we think of ourselves as data science is really changing. So that's something that we'd like to focus on in our discussion today. So I'm going to start. I will introduce our panelists one by one by asking them a question about a key turning point in their career. So what I'd like to know is so probably when you guys studied, not 100% sure when it was, but certainly maybe for some of you, data science didn't exist, right? Like, I didn't graduate from high school and think, data science, that's the one, that's the ticket. So at some point, something happened for you guys where you decided that something that didn't exist, you're now going to do as a career. So what I'm really interested in is, like, was there a turning point in your career that really pushed you into this new field of data science? And what was that? Was it, and did it come across, did you seek it out, or did it just come through fate or some turn? And so I'm going to start by asking Professor Richi Nayak, who is a professor here at QUT, and I believe the Deputy Director of Centre for Data Science. Take it away, Richi.
Thanks, Kate, and thanks to sitting in the panel with the wonderful people around here. And thank you everyone for attending the panel as well. So I may slightly disagree with Kate that data science did not existed. So in about 25 years back, I was doing bachelor's in electrical engineering, and once I graduated, I did the master's. And during the master's, actually, I would say that was my first turning point. My professor introduced me to neural networks. So I'm talking about the early 90s or mid 90s. And that's where I proposed a neural network-based solution for the unit commitment problem, very much into the electrical engineering. But that's where I came to know the power of this machine learning techniques. So what I would say that data science may not exist as a term, but there were always different terms that kind of pointed towards the data science. So those terms at that point of time, we still used to call machine learning. And then I got into my PhD, did the neural network related PhD. But another turning point came in about like late 90s or 2000s, when that internet boom and so much of text data, web data, started to appearing, and I got into the text data mining, XML data mining, and I kind of stayed into that field and is still doing text mining. But now it looks like that life has taken the full circle. I'm now again working on deep learning, the bigger and larger neural networks.
Awesome. Thank you, Richi. So next of all, I'm going to introduce Associate Professor Divya Mehta, who is an Associate Professor here at QUT, co-leads the sports systems domain in Centre for Data Science, and is a biostatistician and geneticist. Richi, turning point.
So my background, I'm a geneticist, which means for my PhD and my postdoc, I used to work in the lab. I used to do all the pipetting. And for me, I guess the turning point was after doing all this work, we ended up with lots and lots of data of lots and lots of genes. And so I had to work with groups of statisticians to understand what these genes are, what did they do, how were these involved in diseases. And that's when I realized there was a bit of a gap, because like they would just give me, numbers, and I was interested in the biology. So I kind of got more and more interested in analyzing the data myself. So I used to sit with the statisticians, try to explain to them what we wanted, try to understand what they are giving us as an output. And then I kind of actually switched. So I'm actually a wet lab person who's now become a dry lab person in the last 10 years. So I just started kind of understanding that the future, even in genetics, is understanding and interpreting the data myself and working together with other kind of, statisticians and biologists together. So I kind of wanted to build a bridge. So in the last, like 8 to 10 years, I've actually switched I think what was really important for me was to have a really good mentor at that time who actually saw that I had that capacity, because not everyone, kind of wanted to do this kind of switch. People who work in labs want to work in the labs. People who analyze data wanted to analyze data, but there are a few of us who, like to do a bit of both. And as you've seen in Rachel's talk, I think it's really important, because having this insight into what happens behind the scene to get the data is important to allow me to analyze it with some more kind of insight into what's happening, right? So that's, I think my shift really is kind of really seeing that I need to, that's the future for genetics.
Thanks, Divya. And up next, I'd like to introduce Dr. Bernadette Giuffrida, who is the Assistant Director for Australian Bureau of Statistics and the ABS Co-Chair of Government Statistics in CDS. We're really lucky to have someone with Bernadette's expertise in CDS. So, turning points.
Thanks, Kate. So I'm going to highlight 2 turning points for me. So my PhD was in chemistry, and I worked in molecular modelling, so drug design, and I kind of got to the point where the trajectory I was on, I'd gotten as far as I wanted to in terms of the interest level that I had in that particular area. And what really drove me when I was doing it and I was thinking about what it is I wanted to do was drawing the insights from the data. And I was at a stage in my life where I was looking to start a family and wanting some job security, and knowing that I was not on a trajectory I wanted to continue on, I made a switch to the Australian Bureau of Statistics, where I figured, what a great place to work with data. And not having quite the right background, I guess I've had another turning point in the last 5 years where, along with the Bureau, I've been seeing that there's all this potential of new data sources, and the ways that we can apply methods to the data, and tapping into the university expertise has really been important. So in the last 5 years, I've actually started a master's in survey and data science myself, to try and encompass and get that personal expertise, because it is such an emerging field.
Great, thanks, Bernadette. And I'd like to introduce Dr. Char-lee McLennan from QUT Business School, who co-leads the social systems domain in Centre for Data Science.
Thank you, Kate. So I had a bit of a convoluted story really to get to where I am. I grew up in a small country town in Char-lee, and at that point I thought I was going to own my own restaurant or something like that. I did maths in high school, but I had a terrible teacher in grade 10, so I actually dropped out in grade 11 and 12. Then my mum always said to me, you need to go away to uni, you can't just stay in a small country town your whole life. So off I went to university, and I started to get more and more into maths and statistics while I was there, and econometrics and things like that, and I just really got interested in it. And then when I finished my honours at Griffith, I was given a job at Gold Coast City Council as a tourism research officer. And from there, I got headhunted by Tourism Research Australia, and I went down and managed the International Visitor Survey down there for several years. And that just got me on my data science journey, because they taught me SAS, which is a horrible program to learn. But and here I am many years later with a PhD, and I'm still doing business statistics and looking at tourism economics and things like that. So.
Wonderful, thanks, Char-lee. And last but not least, we've got Dr. Ides Wong, who is the data strategy lead at the Queensland Department of Health. So it's great to have you here at QUT. Thanks for coming. Turning points.
Thank you so much, Kate. So I guess my turning point, one is the PhD. So my background is in behavioral science. So there's always a little bit of research methodology, GPS signal. That was my part of my PhD. That was super fun. And then I did a postdoc in mental health and kind of parked it, and joined also in government, went to Queensland Health and did a few public sector thing, chasing the job security and just like a broader variety of fun stuff. I've always just been really attracted to be doing kind of fun things and asking really fun questions, because my philosophy is always about, if you ask the right question, then you're 80% there. 2 and a bit years ago, I got a call to say, hey, there's a little thing, I'm not sure if you've heard of it, called COVID, and we need someone to manage it. And that was a 2-week secondment that I thought, that sounds like a lot of fun. It turned out to be a lot of fun, but also a lot of not so fun. But a lot of our COVID response is about data. right? Data about, epi data, but also and genetics, and also COVID vaccine and population movement, transport, mobility. So my role then became data strategy lead, looking at genomics, biobanking, all the really cool and fun stuff. So that was the 2 turning points.
Awesome, thank you. Great to hear about, such the diversity of how people get here to data science. And that kind of leads into my next question, which is, because we have this data science network and we have the Centre for Data Science, it's becoming really comfortable for us to think about and talk about and market ourselves as data scientists. But you all come from really different schools, right? There's not a school for data science, and by and large, you guys aren't from the school of statistics, And so what I'm wondering is, in the ecosystem of the university and the school or your departments, how does it work to be a data scientist in that structure and ecosystem?
Can I have a crack at that question? Because that's something that I really, grapple with, because I'm not a coder and I'm not a techie. And so, kind of pitching at myself as that. One thing, so I work with a lot of digital and tech people, and they really appreciate what I bring to the table. And what they say is, you're not a techie, but you're a people techie.
Yeah.
You help people understand what is the problem and ask the question in a way that we can do cool techie things and give you the answer. And that's, how I position myself as a data scientist. I think in different disciplines, it's still quite challenging, because people think data scientists, you have to code, you have to be able to write programs and all that sort of stuff. So it just depends. Yeah.
And is it mostly a team of data scientists that you're working with and communicating with non-data scientists, or how does that work?
Different data scientists, data architects, enterprise architects in different areas. So a lot of what I do is really understand what is the problem that we're trying to address, what is the question, what's the data, and then suss out the people who know these things, and then try to put them together in a group and really ask those kind of really simple questions that I think it sounds really stupid, but they're basic questions, so people are actually starting from the same foundation. Yeah.
Nice. And what about you, Char-lee? Because you're from the School of Business, which, maybe is not filled with data scientists. How does it work there?
Well, yeah, that's true. There's some people who are more qualitative in business, but there's also some who are very quant. And so I think everyone has got an element of data science skills, right? It's in a university anyway, because we all have that research methodology and that sort of thing. It's just there's some people who like to quantify everything, and that's probably who I am. Everything gets turned into a number. But the biggest role that I play is probably a translator. I translate the data science component into something that's useful for business researchers to use and businesses. So, for example, the project that we're doing with Hastings Steering, one of the biggest aspects of my job is just translating the details around data science into something that's a bit more layman for the businesses to understand and adopt. So, yeah.
Any other people wanting to make a comment on how it works to be a data scientist in your school or department? Yeah.
So I'm in the School of Biomedical Sciences, and so there are a few, just very few people who actually do the kind of analysis that I do. But what's been interesting is there's been a shift now in the university. So we actually have subjects and modules where we're teaching. So it's called quantitative skills for molecular biologists that we teach. And so from the beginning, we're trying to kind of, get the quantitative skills and the statistical methods and all of this into the curriculum so that people can start kind of early on. And that gives them that upper edge, just, for example, just not by working in the lab, but you can obviously analyze some of your own data, which is really valuable, I think. Not just being in one or the other, but rather having a bit of both. So I think there is a bit of a change, at least in biology, where people are getting more involved in data analytics.
Nice. Okay, my next question is about data science, the field, and how you guys think it's changed in the past 5 years. So where we are now versus 5 years ago, what are the big changes, do you think? And I might start with you, Richi.
So I'll kind of tell more from the text analytics point of it. That's my expertise. So in text analytics, we would have never thought a system like GPT-3. So GPT-3 is a Google translator. And you may have heard this story about just last week or so that a Google employee sent a Twitter tweet that a chatbot has become sentient. And that's where we are. And he thought that chatbot is sentient because the way the chatbot was responding, it was almost like human-like. And that's where now the state of the text analytics is there. We have improved so much on the data collection, then data analytics, and making these language models. These language models almost work like us because we have got this processing capability. Now the machines have got that storage and processing capability that they can almost inference like how we do. So that's how the state of the text mining has moved. And the same thing for data mining in terms of all the deep learning. Like if you think about the computer vision, NLP, speech, these fields have so much advanced with deep learning that we would have never thought about like 5 years back. So that's where I would say.
Wait, now, Richi, you've walked right into it. You have to tell me, but you're only allowed a yes or a no. Is the chatbot sentient?
No.
Okay.
No.
You heard it here first, folks.
Because in a way, if we have that much data and if it's trained properly without having bias and variance, the machines have got that capability. And I guess that's where we are now moving. We have got very trained uphill trajectory in this field. Anyway, so how data science has changed in the past 5 years, Bernadette?
Yeah, so I'm trying to think of the exact time. Time seems to be a bit of a blur, but I feel like 5 years ago we probably didn't have data scientist roles in the ABS. We had, mathematical statisticians, we had data analysts, but it's really probably been the last 5 years where there's been a bit more of an embracing of data science as a role in and of itself, and an understanding that we need to get across some of these techniques, and there really is a place for still having official statistics and rigor and all those wonderful things, but making use of these techniques to automate some of our processes and make use of some of the novel data sources that are coming out. So it's interesting as well because they are actually reviewing in the ANSCO, so the job classifications data scientist, and I guess that's to reflect that as an emerging role, it's due for an update.
Sorry, I will come to you, but just one clarifying question. In the ABS right now, so internally you might call yourself a data scientist. Is there like an external branding of saying like, I'm a data scientist who works at the ABS at the moment?
I'm pretty sure, but that's in part of my job title.
Okay, right.
Absolutely, and we have senior data scientists. There's certain areas that everyone in those areas are designated data scientists because of the methods that we're exploring.
Cool. Sorry, Char-lee.
Yeah, I was just going to say that we've seen that real uplift in the recognition of data science over the last 5 to 10 years, and even in businesses now that we're seeing that shift as well. And so I think Richi might have said it in the video at the beginning that now businesses are seeking us out. Like they're literally, I don't even need to look for work. They're just coming and finding me. I'm trying to almost get away from it, but it's a good place to be in. That businesses think they're further back than what they are. They have a perception that they don't know anything, but they know a bit already. They're already doing some. It's just helping them get better and better.
And so does that make it really easy to be a current student about to become a badged data scientist, or does it make it hard because suddenly your job is amorphous?
Well, at the moment, we have a really big skills shortage in data science. Like I struggle to get good people. I know businesses are struggling to get good people, and business is firing at the moment, like as in firing as in it's got lots of money, they're growing and developing. So they're hiring lots of people. So it's getting even harder to get good data scientists. So we've got this skill shortage at the moment. So I think it's a good area to be in if you're going to go into it. It's just, lots of people are moving into the space as well, but everyone needs to have the skill set to a degree. So, yeah.
I might move to my next question, which is, and we heard a bit about this from Rachel, which I think was awesome because she was focusing on this like ethics side. But what do you guys think does or more interestingly, doesn't work in data science right now? Right now, not what we see coming, but at the moment, what isn't and maybe is working?
I'm going to start. I think one of the things that's kind of we're at a very exciting juncture that social science is part of data science. In some disciplines, absolutely. In some disciplines, they go, oh, explain to me how that works. So I think that's one of the part. The other thing is in healthcare as well, and I know Rachel has written some really good quality articles about that, is that diversity is so important. When we talk about AI, when we're lacking that diversity in the questions that we are asking, the interpretation can be a little bit tainted. So data itself is not inert. I think Kerry also talked about we all bring our own accent, our perspective to it. So how we ask the question, how we analyze that, unless we have that kind of complex, nuanced questions and coming from a diverse group, the answer you get is going to be quite a sanitized one, and that is not going to apply. So in a healthcare context, with minorities, with Indigenous populations, I think that's a pitfall.
Great. Anyone else willing to either insult or compliment data science?
Well, I'll add that, well, not add, but maybe go on a different tangent a little bit, is one area that we need to be pushing into is more large collaborative projects, but we really struggle in that space to do good collaborative projects because everyone wants to own the data. They think it's a source of competitive advantage or something like that, or they want to own the platform. And so there's a real issue there that no one wants to really collaborate. And then when they do start to collaborate, all the legalities of things come up. So that's, yeah.
Is that a problem that like we should try and solve as data scientists, or is that actually a problem for like lawyers?
Look, I think it has to be driven a little bit by the data scientists because they understand the underlying issues. Like, how do you get the systems to work properly and integrate? And then how do you integrate data and things? If you don't have that data science understanding, you can't recommend particular laws and things that need to come about.
And also lawyers could be data scientists.
Good point, good point. Yeah, of course, Richi.
I said we are somehow at risk of over abusing the power of machine learning as such. I guess we are now making the transition from a statistical, that is the exploration of the data, to predictive, where we are making this predictive and the futuristic kind of thing. And organizations not really realizing that data exploration or the simple statistical like regression techniques may be sufficient. But just because everybody is at race of like machine learning, deep learning, all the giant techs they hear about like driverless cars and so on. So everybody is trying to be in that risk. And sometimes I say that we should not be really abusing machine learning. For so many applications, we do not need these sophisticated applications, just the data understanding.
What should we do if I'm not a machine learning specialist necessarily, but like what should a machine learning specialist do to make sure they're not like adding to that problem?
Yeah, I guess what everybody's saying, that a collaboration and working with the domain experts and letting them realize that what do they need. There is not really a need of very complex analytics here. Just the simple techniques would suffice to this job. So I guess this collaboration, working along, and just the education, what is really needed for this futuristic approach.
And Ides, that might be something that you saw a lot of at the beginning of COVID, like everyone write a COVID paper, I think.
Totally, and I really think Richi and also Char-lee's point about, because one of the points is data access governance. Yeah, data, it is really important, particularly health data, but also driver's license data. Those are important information. And how do we use it in a way that makes sure privacy is respected and data sovereignty is respected as well? So I think that's probably a great area that if there's any lawyers in the crowd, please come and be data scientists with us.
What about you, Bernadette? What do you think, like things that are not working in data science at the moment?
I completely agree with Richi about the pitfalls of trying to apply things like machine learning to everything. I'm very conscious at the ABS about considering sophisticated techniques like that as something in our toolkit, but not necessarily the first thing that we try. And we always, compare some of the simpler methods first. the collaboration part is really, really important because it's impossible to be across everything. And the more conversations I have with people in academia and other universities and even just in other organisations in the Australian Public Service, it's really apparent that there's lots of pockets of expertise to tap into, and making those connections is really important. So you're not going to the toolkit and pulling out something that might be an improvement, but it's not the best thing. It's not appropriate. And to speed that process along, the collaboration is really important, but it is very challenging. Yeah. And I think it's the more the more well trodden that path is, the easier these things will become. So yeah, it's something worth continuing and persevering with.
Divya?
I think so from my area of genetics, so we've obviously moved into the big data. So we've got lots and lots of data. But the issue is it's not always good data. So that's an issue. There are no processes or streamlined like methods that tell you what is a good way to collect data. So often we do have large collaborative efforts in genetics, but standardization of data across groups is very difficult. So, if you're collecting genetics data in Australia versus the US or any other country, to get it all, bringing it all together is a nightmare. So I think that's been an issue for us, is to actually have some kind of, people are now developing, methods and pipelines, good practices, standard practices in genetics data. But yeah, it's big data. So everyone wants to collect lots and lots of data, but it's often missing, or it's not done in the correct way or in the same way across centers. So with the large collaborative efforts, what we are now trying to do is, when you have, you write a grant, you have a whole set of kind of guidelines of how to collect the data. This could be not just genetics, but it could be clinical or any other kind of data as well, because standardizing data is the main thing. So yeah, we can all collect data. We can all try to put it together, but if it's not standardized well enough, if it's not, kind of measured correctly, then it's just junk data. So I think it's kind of a shift from the big data to the good data. I think that's kind of pretty important. Yeah.
Okay, so we've looked at the past 5 years, we've looked a bit at at the situation right now. And if I let you guys cast your minds forward to like the best case scenario in the next 5 years, or like your dream 10-year situation from your various kind of application fields or applications that you know about, what's the next big problem that you're really excited, not the next, but like a big problem you're excited for data science to be able to solve that is realistic on a 5 or 10 year horizon? Richi, shall we start with you? Yep.
Yeah. So I always say, like, people do say artificial intelligence field or artificial intelligence technology. So I would say at this point of time, there is not really any advancement in AI, what it is in machine learning. So we are still at a machine learning stage. So it means we are just making machines to learn the patterns. So we are at the pattern recognition. We are not really inferencing or reasoning state. I would think with the quantum computing and all those things, with the good data collaboration with the domain experts and so on, we should be able to reach where machines can actually inference just like humans. And I guess that would be the next state of development, where we get the AI much beyond what machine learning is.
And to clarify, is this going to be sentient robots that are coming out and killing us in the next 10 years? Or
So I guess the robots would not still be sentient, but the way we would train them, the computational, the data resources that we would have, I guess the diversity. So we would have not just the one source of data, but data coming from multiple diverse sources. And we would make sure that the training has been done correctly. So now these non-sentient beings would almost be like sentient.
And I guess like the ethics that we've thought about today is like going to be core to that journey.
Exactly.
Yeah. What about you, Divya?
Obviously, I guess for my sector, healthcare would be really, can drastically change if we use data correctly. And yeah, I mean, we are all collecting data all the time. So it's just, like I said, a question of really figuring out how to best use it for our, kind of healthcare system and, health and drugs and other things. So I think that could be a huge thing. And we are obviously getting there. I just, you have spoken about COVID, and that's been a big kind of, example where we've used a lot of data for healthcare and, vaccines and drug repositioning and things like that. So, I think we're getting there. It's happening slowly. And obviously for us, it's collaborations. And as you said, I think everyone working together so that, and it is happening now, often when we write grants, because I've been on grant panels where people basically, if you're any kind of project that has data, they want to be sure that there is somebody on the team who can actually understand and interpret and analyze this well. So I think it's becoming quite, data scientists and data science is getting kind of embedded in almost every project or everything. So I think that's the way we're shifting, really.
So for you, like the 5-year plan is like an integrated and adaptable workforce of data scientists who can kind of tackle problems as they come
Exactly,
up.
yeah. So I mean, like for instance, I work on a lot of different projects, and someone has recently come to me with some kind of health economics project, which I've never done before, but it is a part of what I do. And so it's kind of being a data scientist, it's exciting because you can actually be involved in a lot of different types of projects. So you can use your same skills to kind of answer different questions and find solutions for a range of different problems. It doesn't have to be, so obviously my focus is mental health, but I can use it for health economics, I can use it for business modeling of any other kind of data. So even shares and things like that. So
You can fix my brain and my bank account with data science. You heard it here. Bernadette, so 5-year vision, what problem do you want to see solved?
So what I'd like to see, and I don't know how realistic this is to see like a real synergy between survey data, administrative data, some of these more novel data sources, imagery, to be able to produce official statistics and really have grounded with really good, strong quality frameworks and measures of uncertainty. So, people, there's a reduction in burden for responders who are filling out surveys, and we can respond to things really quickly. And we're certainly, that's what we're aiming for organisationally, but it's a big journey. Yeah.
Nice. Char-lee?
Probably building on that. So I'm going to start with, we're doing a lot of work at the moment in strategic planning for data science. So a lot of data science strategies and things like that one, we're doing it with the Department of Resources at the moment with Frontier SI. And we've got a lot of conversation going on around large collaborative projects across government, federally, locally, all of that to lead towards like what would be like a long-term monitoring project in like a digital twin sort of framework, I guess. So that I can see being a really big push over the next 5 to 10 years, particularly given we're going to have the Olympic Games here in Queensland, and we need to be able to know the impacts of that because, usually such games blow out almost by double, right? So, having good guidance around that can help us not only understand how to do good governance around the games beforehand, but also then monitor the impacts afterwards to inform other games in the future. And then lastly, I know there's going to be a big shift in our labour market over that time because as Richi was saying, we're going to be doing things differently. We're going to have bots that are going to do things differently. Think about it from an academic point of view. Where will we be in 10 years? We might not be doing the work we do right now. We'll be doing something different. So, yeah.
Ides.
In 5 years, I think in terms of health anyways, and that's really a personal vision of mine. One of the things is that, we're moving from descriptive to predictive analytics. So about predicting, what kind of medicine and what kind of treatment a person would be suitable for, and digital twin modeling, patient flow management in a hospital system, because there's no, we're always talking about healthcare transformation. There's no transformation without digital and data, in a 21st century scenario. That is just not going to happen. The other thing in terms of personalized medicine is how many of you go to the GP, get a prescription and go, most people kind of work, don't quite know, but let's try it out. What if you have actually data available to the GP and say, hey, look at my history, all these data, it looks like this may not work for me. We can skip all those and go to something that may be more suitable for me. So that's kind of personalized medicine journey in terms of providing data to the consumer at point of care And in 5 years, we can definitely do that.
Really? Like we're 5 years away
Fingers
from...
crossed.
That's awesome.
Yes.
Okay.
May not be Queensland Health, maybe from somewhere else, but that's my vision. And I think definitely achievable.
Amazing. Thank you so much. And thank you to all of the panel for the inspiring, now we're going to solve the world in 5 years messaging. So I'd like to thank, that's the end of our time on the panel and for our formal part of this session.